Hey guys, so today we're going to do another example of solving trig equations with multiple angles. And so here again we're given this problem where we have sine, and this time it's 3x, so that makes it really tough to solve normally. And I'm going to do again what I do. It's my method. You don't have to do it. You can do this in a lot of different ways, but either way you'll arrive at the same answer. So what I do is I set whatever is inside here, and I set that equal to some new variable I call y. So now I'm left with 2 sine y plus square root of 3 equals 0. And then now I can't just do that and not change my interval, because this is the x interval. And now I'm solving for this new variable y, so I need to make a y interval. And I know the relationship is 3x equals y, so 3 times my x interval is going to give me my y interval. So you can pretty much just distribute. We're going to get 3 and then times 0. This will give us the lower end of our y interval. 3 times 0 equals 0. So that's where the y interval starts. So I'll say y interval beginning. Then we're going to get 3 times 2 pi, because that's where the x interval ends. And that's going to give us 6 pi, which will be our y interval ending. So our interval can be seen as 0 to 6 pi. And what you could have done is you could have just done 3 times like 0 to 2 pi and kind of just distributed, to get 0 and 6 pi. Either way, you'll get the same thing. I just wanted to try to make it as clear as it could be that we're taking the 3, because that's the relationship, and instead of just an x, we're putting in the x interval, and instead of a y, we're getting the y interval. So now that we've got that, we can just solve for this equation here and just plug in our, and just make sure we solve from 0 to 6 pi. So we know how to solve this. We isolate the sign first. So we're going to get 2 sine y equals negative square root of 3. Then we're going to divide by 2. So sine y equals negative root 3 over 2. And now what I'm going to do is I'm going to, figure out what quadrants we're working with. We've got sine equals negative root 3 over 2. So I think about, my mnemonic device is all students take calculus. Everything's positive here, or all. And then students is S, so that's sine is positive, and then tangent's positive, and then cosine's positive. So if my sine is negative, I've got to be working with these two quadrants. Let's think about it. We're at negative root 3 over 2. So that's going to be these angles that are closer to the middle. Going to be that one and that one. Let's think about where that is. This is 3 pi over 3. That's going to be 4 pi over 3. Then we're going up another pi over 3. We're going to be at 5 pi over 3. Okay, so we've got y equals 4 pi over 3. Then remember, our interval is from 0 to 6 pi. So we've got to do 4 pi over 3 plus 2k pi. Then we've got y equals 5 pi over 3 plus 2k pi. And we got to make sure we get it from 0 to 6 pi. Okay, so if we go 2 pi over 3 from this one, 4 pi over 3, we're going to just add, 2 pi over 3 is 6 pi over 3. So we're going to add 6 pi over 3, we'll get y equals, we have 4 pi over 3. Then we're getting to 10 pi over 3. Still less than our 6 pi. And then we have to add another 6 pi over 3. We're going to get to 16 pi over 3. And then if we add another one, we're at, 22 pi over 3. And let's check what would be greater than 6 pi. Anything over 18 pi on top, that's 22. So that's going to be an x. Let me just erase that one. So these are the three solutions for y using this one, and now we need to find them for this one. And we've got 5 pi over 3, and again we're going to be adding the 6 pi over 3, because that's what 2 pi is with a denominator of 3. So just adding 6 to the top pretty much. So then 11 pi over 3, which is still a lot less than 6 pi, and then we've got to add 6 more, 17 pi over 3. And as you can tell, that's getting really close to 6 pi. The next one would be 23 pi over 3. That's a really bad 23, but that's over 6 pi, so that's not going to count. So these are our y values, and now we have to get our x values. We know that 3x equals y, and we have all these values of y now. So we can take them all and divide by 3, and x, because x equals y divided by 3. So what that's going to do is if, let's, for example, take 4 pi over 3 and divide it by 3, all we're going to do is change this denominator right there. This denominator here is going to change from 3 to 9. So we're going to get 4 pi over 9. And then, as you can see, every single one's got the same denominator of 3. All of them are going to just be changed to 9s. So x equals 4 pi over 9, 10 pi over 9. We're just changing them all to 9, 16 pi over 9, 5 pi over 9, 11 pi over 9, and 17 pi over 9. There are a lot of different ways to do this, but this is my preferred method, and as you can see, we go from 4 pi over 9 being our first one, that's greater than 0, and then we go from 17 pi over 9 being our last one, that's a barely less than 2 pi, so they're all within this original x interval, which is what we wanted to do, and they all make the problem work. So these are the solutions to that problem. That was a little long, but I hope you understand what I was doing here. If you have any questions, let me know. Again, there are multiple methods to solve these. This is just the way I like to do them. I hope this was able to help.